Where I want to start our review today is just what probability is. The probability of any given event. How do we define that? Start back with the algebra readiness concept of probability. What is the definition? How do I find out how likely an event is to occur? Okay, how many times did it happen compared to how many times you tried it? Yeah, that's exactly the definition of probability. It's the number of successes over the number of tries. Or possibilities. So for example, if I talk about probability of pulling out the Jack of Diamonds from a deck of cards, that's one specific card out of 52 cards, which in decimal form, 1 divided by 52, puts me at 0.019, which converts to 1.9%. Now watch with the percents. A lot of what you're going to be asked to do will say, give me the probability as a decimal. It'll say, give me the probability as a percent probability. So make sure you shift that decimal point when you go from the decimal to the percentage. We could also talk about the probability of rolling a snake eyes on 2 dice. And these are standard 6-sided dice. Since we're not doing a formal probability unit, we're doing geometric probability. I won't play with the non-6-sided dice, but they do exist. There are dice that have 4 sides, dice that have 8 sides, dice that have 10 sides, dice that have 12 sides, dice that have 20 sides, dice that have 30 sides, and I actually did see a die with 100 sides. Actually, it wasn't a die. It was a ball that had a ball bearing in it that would weight it so it would stop rolling at a certain point with a number on top. It was a way of randomly generating numbers from 1 to 100. You can also do that with 2 D10s, but that's just the gamer geek in me. How many different ways can I get snake eyes, which is a 1 and 2 ones with 2 dice? That's one way I can do it, right? I have to roll a 1 and a 1. And there are 36 combinations of dice outcomes. So that's 1 out of 36. So 1 divided by 36 puts me at 0.027 or 0.27%. This is review, right? We've done this stuff before. All right, now we're going to be looking at with geometric probability is when they're not discrete events, but parts of continuums. So the first one we're going to look at today has to do with this. Pedestrian signal at a crosswalk has this cycle: 45 seconds of walk and 70 seconds of don't walk. So what's the probability when I walk up to the signal, I can just start walking across the street? How likely is that to happen? Give me a calculator. That's a good sign. There are the 2 things I'm going to be dividing. The wins versus total. So what would represent wins in this case? How much of a range am I looking at? 45 seconds. Maybe 39%. We'll see in a second. So probability of an event A. Just whatever the event is. So that's 45 seconds. Represents I can walk across the street. How many total do I consider? 115. Common mistake is to say 70. But there are 115 total seconds available to me. So I do 115 divided by 45. Try it again. 115 divided by 45. You know, it would help if I went 45 divided by 115. There we go. Like, why do I keep getting 2? 0.39, which is the same as 39% of the time I can walk right across. Now, here's a nice way of checking yourself. That's what I was doing with this and why I was struggling, is probabilities. the probability of any event is always going to be less than 1, greater than 0. You will always get a decimal. If you ever get something like 5 as your event probability, you did it wrong, go back and look again. If you get a negative, go back, try again. Also part of our review. What's it mean if the probability of an event is 1? Always happening. And then the other extreme, never. Never going to get it. 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 And now I show my age because none of you guys recognize that as a song. Darn. It's okay. Not too bad, is it? It kind of feels like this part of the unit is like, yeah, this is stuff you did last year, right? Or the year before.